Imagine the roar of engines igniting, a colossal rocket trembling as it fights against gravity's pull. The ground shakes, and a plume of fire and smoke fills the air. This is the spectacle of a rocket launch, a testament to human ingenuity and our unyielding desire to explore the cosmos. With incredible force, we hurl these sophisticated machines skyward, sending them on journeys to deliver satellites, gather scientific data, or even carry astronauts to the International Space Station. But the journey into space is only half the story. Like a boomerang, these missions are designed to return to Earth, and that's where things get really interesting. Picture this. Our spacecraft is hurtling back towards Earth at an incredible speed. As it slams into the atmosphere, it compresses the air in front of it, like an invisible wall. This compression generates immense heat, causing the air around the spacecraft to reach temperatures hotter than the surface of the sun. This extreme heat isn't the only challenge. The friction generated by the spacecraft rubbing against the atmosphere acts like an invisible brake pad, trying to slow it down. This deceleration force is so powerful that it can create immense pressure on the spacecraft, threatening to crush it like a tin can. To survive this fiery plunge, spacecraft need a way to withstand both the extreme heat and the crushing pressure of re-entry. That's where some ingenious engineering comes in. Enter the heat shield, a remarkable piece of technology that acts like a protective shell for the spacecraft. This shield is crucial for ensuring that the spacecraft can survive the extreme conditions of re-entry. Without it, the intense heat generated by the friction between the spacecraft and the atmosphere would be catastrophic. This shield isn't just any ordinary metal plate, it's designed to burn away in a controlled manner, carrying away the intense heat of re-entry. The material used in the heat shield is known as ablative material. As it burns away, it absorbs and dissipates the heat, preventing it from reaching the spacecraft's interior. Think of it like a bar of soap melting under hot water. Just as the soap gradually wears away, the heat shield's outer layers vaporize, taking the heat with them. This process is meticulously engineered to ensure that the spacecraft remains at a safe temperature throughout its descent. As the heat shield encounters the searing temperatures of the atmosphere, its outer layers vaporize, carrying away the heat energy and protecting the spacecraft beneath. This vaporization process is not random, it's a carefully calculated reaction that ensures the spacecraft can withstand the harshest conditions. But heat isn't the only concern. The spacecraft also faces immense pressure as it plummets back to Earth. The combination of high speed and atmospheric resistance creates a force that could easily crush the spacecraft if not properly managed. To manage the crushing pressure of re-entry, engineers have devised clever techniques to control the spacecraft's descent. These techniques are the result of years of research and testing, ensuring that every aspect of the re-entry process is accounted for. One such technique involves using the atmosphere itself as a braking system. By leveraging the natural resistance of the atmosphere, engineers can slow down the spacecraft without relying solely on mechanical brakes or thrusters. By carefully adjusting the angle of the spacecraft, engineers can use the atmospheric drag to slow it down gradually, like a surfer riding a wave. This method not only reduces the speed of descent, but also helps to distribute the forces evenly across the spacecraft, minimizing the risk of structural damage. This controlled descent helps to reduce the G-forces experienced by the astronauts and prevents the spacecraft from being ripped apart by the intense pressure. The safety of the crew is paramount, and these technologies ensure that they can return to Earth safely, ready to share their experiences and discoveries. Section 4. Triumphant Landings, Success Stories from Space. Over the decades, we've witnessed some incredible feats of engineering when it comes to spacecraft re-entry and landing. These moments are not just about the technology, but also about the human spirit and the relentless pursuit of knowledge and exploration. Each successful landing is a culmination of years of hard work, dedication, and the collective effort of countless individuals. From the early days of the space race to modern reusable rockets, each mission has pushed the boundaries of what's possible. The early missions were fraught with challenges and uncertainties, yet they laid the groundwork for the sophisticated technology we see today. The evolution from single-use rockets to reusable ones marks a significant milestone in space exploration, making it more sustainable and cost-effective. Who could forget the iconic image of Apollo 11's command module splashing down the Pacific Ocean? This moment was not just a triumph for NASA but for humanity as a whole. It symbolized the culmination of a dream that had been nurtured for centuries, the dream of reaching the stars and returning safely to tell the tale. The Apollo missions, with their groundbreaking achievements, continue to inspire generations of scientists, engineers, and dreamers, or the heart-stopping moment when the space shuttle touched down on the runway, its nose pointing skyward like a bird returning to its nest. The space shuttle program was a marvel of engineering, designed to be reusable and capable of carrying both crew and cargo. Each landing was a testament to the precision and skill of the astronauts and ground control teams, who worked in perfect harmony to ensure a safe return. And then there's SpaceX, a company that has revolutionized space travel with its Falcon 9 and Falcon Heavy rockets. SpaceX has not only made space travel more accessible, but has also set new standards for innovation and efficiency. Their approach to reusability has drastically reduced the cost of space missions, opening up new possibilities for exploration and commercial ventures. These incredible machines are designed to not only launch payloads into space but also return to Earth and land vertically, ready to be used again. This capability has transformed the landscape of space travel, making it more sustainable and paving the way for future missions to the Moon, Mars, and beyond. The sight of a rocket landing vertically is a powerful reminder of how far we've come and the potential that lies ahead. These successful missions are a testament to human ingenuity and our unwavering determination to conquer the challenges of space travel. Each mission, each landing, is a story of perseverance, innovation, and the unyielding human spirit. As we look to the future, we can be confident that the lessons learned from these triumphs will guide us to even greater achievements in the vast expanse of space. Section 5. The future of space travel, reusability, and beyond. The ability to safely return spacecraft to Earth is crucial for the future of space exploration. This capability not only ensures the safety of astronauts and cargo, but also opens up new possibilities for long-term missions and sustainable space travel. By reusing spacecraft, we can significantly cut down on the costs and resources required for each mission, making space travel more efficient and environmentally friendly. Reusable rockets, like those developed by SpaceX, have the potential to significantly reduce the cost of space travel, making it more accessible for scientific research, commercial ventures, and even space tourism. These rockets are designed to withstand the harsh conditions of space and re-entry, allowing them to be used multiple times. This innovation is a game-changer, as it lowers the barrier to entry for many organizations and countries that previously couldn't afford to participate in space exploration. Imagine a future where launching a satellite into orbit is as routine as flying across the Atlantic. This vision is becoming more attainable with each successful launch and landing of reusable rockets. The ability to quickly and affordably deploy satellites will revolutionize industries such as telecommunications, weather forecasting, and global positioning systems, providing better services and connectivity to people all around the world. Or a time when humans can travel to Mars and establish a permanent colony, thanks to reusable spacecraft that can ferry people and supplies back and forth. This would mark a new era in human history, where interplanetary travel becomes a reality. The challenges of living on Mars are immense, but with reusable technology, we can continuously send the necessary equipment, food, and other supplies to support a thriving colony. The technology behind spacecraft re-entry and landing is paving the way for these incredible possibilities. Advanced heat shields, precision landing systems, and robust spacecraft designs are all critical components that ensure the safe return of these vehicles. Each successful re-entry and landing brings us one step closer to making routine space travel a reality. As we continue to push the boundaries of space exploration, one thing is certain: the fiery plunge through Earth's atmosphere will always be a critical and awe-inspiring part of the journey. This dramatic re-entry is not just a technical challenge, but also a testament to human ingenuity and our relentless pursuit of exploring the unknown. The sight of a spacecraft glowing as it re-enters the atmosphere is a powerful reminder of the incredible feats we are capable of achieving.